Welcome, everybody. Enjoying Houston so far? This is in the hot season. The hot season is, it's bad. It's really bad here. It's like New Orleans hot. Have you ever been to New Orleans? I was the guy in Bourbon Street last year during Tech Ed walking down the street with a gym towel on his back, just wiping my face every couple of minutes. But thanks for coming in. We're going to talk about a topic that should be mainstream, and proof of the size of the crowd in here. But judging by the size of the crowd, it's still not mainstream, and it definitely should be, which is one of the reasons I continue to talk about it. That, and it's a very, very cool topic, dependency injection. I do want to call this quick poll real quick. Who in here uses DI on a regular basis, like in mainstream app development? See, not that many. There's quite a few hands, but they're really, really scattered. Who would like to? No, it's supposed to be everybody. Because if it's not everybody, then what are you doing in here, right? It's got to be everybody. And I want everybody to raise their hands, just every single person in the room. And just wave it. All right, now we establish that they work. So if I ask a question, you should be able to raise your hands, right? Now, judging by the laughter, I can tell your vocal cords work as well. They got mics set up here for questions. I think the room is small enough where if you yell loud enough, you may not need to get up. But I don't wait till the end of the talk to take Q&A. So if you have a question, just raise your hands and stop me. I'll use my best judgment to guide the length of time that I spend on a question, okay? So we're here to talk about DI and the concepts behind it. And it's these concepts that allow us to do the second part of this title, which is writing decoupled quality and testable software. So has anybody seen any of my sessions before? And you're back for more torture, huh? All right. Have I insulted anybody in this room before? Because I usually make it a point to do that in every single conference I speak, whether I think about it or not. So I'll try my best not to. So I've been doing this for a while. I've been on the conference circuit for a number of years now. I've been in the IT business since 1979. So I'm one of the old farts in the business. And I also got a couple of Pluralsight courses out there. I'm not here to spend a lot of time on them, but they're on my slides. So if you have a Pluralsight subscription, I encourage you to get out there and watch the course. I think you'll enjoy it, and I've gotten some really good feedback from it. So this is what we're going to do. We're going to talk about the stuff that gets us to DI usage, because anytime that I bring up the topic DI in front of a crowd, your brain immediately switches into product mode, and product meaning container, because nobody really uses DI without a container. Even though the concepts of DI have nothing to do with a container, we're going to spend a lot of time on container usage because that's what mainstream DI is all about. But before I can introduce any kind of container product, I have to introduce what these concepts are, because there were a number of people in the room that have not used DI before. And I need to talk about dependencies and coupling and what this is and why it's not good and why getting away from it will facilitate testing. And after I've done that, then we're going to jump into true dependency injection, what the concept of dependency injection is and what the action of it is, what are the things involved in using dependency injection, and then how to use a product to help you out. Because once I've taught you how to do it and how these concepts of abstracted software work, doing it without the help of a container product is almost a waste of time, because we're all out to be as productive as possible. And one of the whole reasons for doing DI is to not only become testable and writing quality code, but also to be as productive as possible in writing code in a much faster way, making your deliverables come across a lot faster. And you do that with the help of a container. I'm going to discuss several containers, but I'm going to focus. I have to pick one, because I can't sit here in 75 minutes and talk about 7 or 8 different containers on how to do everything in each container. Each container merits its own 2-hour session, to be honest with you. I'm going to choose AutoFac, just because it's the one that I use. It's the one that I think it's the more modern container. It has the richest API. Anybody use AutoFac in here? Well, you guys. That's my team right there. We work together, so that's why they use AutoFac. But who uses Unity? Okay, Unity's a good container too. What about Castle? Ninject? Structure map? Okay, get ready for this one. What about MEF? I do too. MEF's a good container. It just has little drawbacks, and I'm going to discuss some of them. So after we talk about container usage, I'm going to go through a lot of stuff of container usage. I have a lot of information to impart to you. Not just basic container usage, but a lot of techniques, patterns, and tips and tricks, because there's some little things that'll bite you in the ass when you're using dependency injection that you got to know about, and there's always a way around them. You just got to know how to get around them. And the thing is, every container has its own way of solving the different problems. So I'm going to show you primarily the AutoFac way, but I will tell you every container has a way of doing everything that I'm going to show you. Some just have a little more limitation than others, and some use different syntax than others. And after I'm done with all of my usage examples, my usage demos, of which I have 9, I have a quick usage scenario set of demos where I actually have set up 4 applications. One is in WPF, one is in ASP.NET MVC, one's in ASP.NET Web Forms, and one's in WCF. And I'm going to show you real-world usage scenarios in all 4 of these things. Now, real quick show of hands, WPF, XAML. Let's just say XAML people. All right, you guys know WPF is back, right? Like a rising force. WPF is awesome. It's my favorite technology, so I'm a big WPF guy. What about ASP.NET MVC? Okay, what about ASP.NET Web Forms? Excellent. Good to see that Web Forms is still alive. Great technology also. I'm going to show you how to use DI with Web Forms, in case you've heard the rumors about it not being possible. What about WCF? And no, Web API has not replaced WCF. But the MVC demos that I'm going to show you apply to Web API as well, so WCF merits its own set of demos. And I stuck those in there at the last moment, which is why I sent you updated code like 2 or 3 days ago, Cesar, because at the last moment I just wanted to put more in there. So here's the shock and awe statement, okay? You notice I say breaking a lifelong habit, and this is where I tell people a certain rule of thumb that I'm going to ask you to go by that's going to take some people by surprise, and others it's going to make sense to you, but I'll explain it either way. So what class coupling is all about is very, very simple. Most everybody in this room probably understands it, so I'm not going to spend a whole lot of time on it. It's all about one class depending on another, and a lot of times this is all embedded in the code, which means a class cannot compile without the existence of another. So let me set real quickly the case study example that I'm going to use throughout the entire 75 minutes, and that's a simple commerce class that's going to process an order coming in from a shopping cart, let's say, an online e-commerce site, right? And it takes a certain amount of steps to fully process an order. Updating customer information, processing credit card information, sending out email notification that your order's been processed, and maybe even some logging with some cool login tool if you want. And I've broken these 4 different steps out into subcomponents so they can be made more autonomous and so they can be tested a lot easier. So we're going to have a commerce class that's going to depend on 4 other classes. Now, the first example I'm going to show you is a coupled example where the commerce class will not even compile without its dependent classes. The main thing is not that. The main thing is the lack of testability. And what I mean by that is that if you have a commerce class that uses a sub-dependent class called a billing processor, think about what that billing processor does. It's going to process your credit card. What about another processor, another class? I call these processor classes. What about another class that updates the database with your customer and order information? Now, if you're going to take a unit test and instantiate the commerce class, you're now also instantiating these dependent classes. And you're coupling and tying yourself to the act of updating a database and, worse, processing a credit card. So your unit test is not autonomous. Your unit test is not what they call it in the service-oriented world, idempotent, which means you should be able to run it over and over and over again without causing any damage. Anybody ever hear that term, idempotent? Is that the stupidest word in the world? You can't even pronounce it. I don't know who came up with that, but it's a real word. There goes the English language for you, right? So you should be able to run a unit test over and over again without it causing any harm. And if your unit test is updating the database, that can cause some damage. And at that point, it's not really a unit test. It's more of an integration test. Even worse with something like processing a credit card. So we don't want to have these concrete implementations embedded into our hosting class. And in my case, it would be the commerce class. So what's the secret to all of this? What's the secret to embracing abstractions? It comes down to one very simple rule. In my case, 99.9% of the time, I can follow this rule. Now, the reason I leave you that 0.1% of leeway is because this is software, and you can't have 100% absolutes in software. I don't care what anybody tells you. The words never and always just simply don't apply in our business. There's always going to be an exception case where you're going to have to get the job done, and you're going to have to break some kind of rule. But think of it as the fat intake in diet, right? A lot of dietitians will tell you shoot for 0, and what you end up getting is usually enough fat. Same thing with this. Shoot for following this rule. Now, this is the shock and awe part, because this is where I tell people, stop newing up objects in a class, and 50% of the people immediately get taken back, because it's a tough thing to ask. How many of you in this room have something equals new something else somewhere in a class method that they write today? You see what I mean? Do you think you can do without it? It sounds like it's a very difficult thing to do, but that's why you're sitting in this room. But if you can take this one simple rule and figure out a solution to it, you've embraced complete abstraction. You've embraced complete decoupledness. And you do this through dependency injection. And you assist your dependency injection needs through the help of a container, a dependency injection container. So what you do is you define your dependencies as interfaces. In the world of DI, gone are those days where you only use interfaces when you think you're going to have multiple implementations of one definition. In modern applications that embrace the concept of abstraction, the concept of decoupledness, I'm sure you've heard the term decoupledness quite a bit, every class is abstracted to an interface. And it's always interfaces that classes use to communicate with each other. Okay? So everything that I will write going forward is also defined as an interface. And what happens is the hosting class, in my case it's that commerce class that I have yet to introduce you to, will receive the dependent classes for the processing of billing, the notification, the logging, all that stuff. It will receive them as interface types. And what this is going to allow me to do is that it's going to allow me to send multiple implementations of these interfaces at different points in time. My two primary points in time are production and QA. So in production, I have production versions of these interface implementations that are going to do the true database access, the true credit card processing, the true logging and email notification. At test time, I have a choice of either sending test implementations of these classes or using a mocking tool. Now, a mocking tool is essentially using test implementations of interfaces. It's just letting you set it up using a mocking API instead of physically writing classes. Who's used a mocking tool before? Quite a few people. All right, so this should not be strange to you. Anybody use MockQ? This is the one that I use. What about RhinoMox? Just Mock from Telerik? What else is there? What? Fake It Easy. That's the name of a product, Fake It Easy. I would use that just because of the coolness of the name. That is great. And then Microsoft's got something that I haven't used yet called Fakes, I think. And I don't know if that's an actual mocking tool or not, but it's in that same arena, if I'm not mistaken. But I can't. It's like Just Mock? Now, all of these mocking tools do the same kind of thing. They just have, it's like a DI container. You got to pick which one you like better, which one has syntax that you actually like. All right. So let's go over to a couple of examples. Now, the demos that I have for you, I'm going to warn you, the running of the demo is actually very, very boring. They all come out with the exact same output. So I'm not here to show you a lot of output to the console because all the demos look the same. What's important is the code behind the scenes. I'm going to, and I also provide a lot more code than what I have time to show you. So let me show you the example of this coupledness that I'm talking about. I got different classes here. Take a look at this billing processor. This billing processor is a class, no interface involved. So this is the bad way. This is the before here, right? So it's a class called billing processor that's got a method called process payment, and this method receives the information necessary to process a credit card. Obviously, for all my demos, all I'm doing is writing out to the console to show you that something has taken place. But in a real application, this will go out and go to some payment gateway, like PayPal or CyberSource or Authorize.net, and actually process a credit card. I can test it for you. Does anybody have a credit card I can borrow real quick? No? That's that old comedian's joke, throw me $1 or throw me a $20 bill type of thing. All right, so I got different processor classes. Here's the customer class where it's going to update the customer order, and it's just writing out to the console. And then I got my other one. I'm going to show you all four because you're going to see these over and over again through the rest of the hour. I have a logging class that would probably use some kind of tool, maybe Log4Net or the logging application block from Microsoft. Just write out to some kind of log file. And then the notifier will actually send out an email. So all of these classes do what they do very well. They work together in the overall scheme of processing an order, but they do a very specific thing. But what they do is something that doesn't make a lot of sense that in a unit test you repeat over and over again. Think of having the unit test, this class right here, if what it does is physically send out an email receipt each and every time you run the unit test. That would not be a very good unit test. Now, as far as using the class is concerned, here's my commerce class, and as you can see, the classes are embedded within it. As a matter of fact, in the constructor, a very simple default constructor is instantiating all of these. This makes it impossible to test the commerce class without instantiating the 4 inner subclasses. This is the key part to that shock and awe statement that I put on the screen a few minutes ago, where I said don't new up classes anymore. This is exactly what I want to eliminate here. Now, if I run this, it's just going to show those 4 things to the console. So in the interest of time, because I have so much to show you, I'm not going to worry about it. But you're just going to see some console stuff show up, and that's it. When it comes to testing is my problem, because now a unit test, like I said, cannot instantiate this without depending on these. So what's the first order of business in order? And I want to make sure I don't run ahead of my, okay, good. What's the first order of business in fixing my problem? Now, this is before we get into any kind of dependency injection container usage. What I want to do is show you another project called abstraction, which has exactly the same thing. But the difference now is this. Does this look any different to you at all? I've abstracted to an interface here. So now I have 4 identical classes. The only difference is that these classes now implement their own set of interfaces. Here's my interfaces right here. What the implementation for this is should be, in good software, this should be of no concern to the commerce class. All the commerce class cares about is that it receives this so it can do something with these pieces of information. Hopefully, you send the right dependency in so that you can process a payment properly. So now my commerce class is a lot more decoupled, as you can see. My commerce class works only with these interfaces. It doesn't know whether there's real, test, fake, malicious. It really doesn't know, nor should it know. It should be oblivious. It's a hosting class. Its job is just to execute all these steps when it brings these dependencies in through the constructor. Now, I still got a little bit of coupling here, and I'm going to show you where, but I'm on the right track here. The reason I have a little bit of coupling because my host example, my application host, which is my program static main, since it's a console app, is the one that is doing this here. But that's fine, because this isn't typically something that I would test. This is just the kickoff part of the application. If I wanted to test something, if I'm interested in testing something, I'm interested in testing the individual classes to make sure they do what they're supposed to do, in which case that would be more integration testing. And I want to test that the commerce class can have its process order executed without failure. And I do that in a unit test by passing mock implementations of this. So where in this production class you see that I'm passing in real implementations of all of these sub-processor classes, if I go to a unit test now, this unit test is taking each one of those interfaces, iBilling processor, iCustomer, iNotifier, and iLogger, right here, and creating a mock. And how it does this depends on your mocking tool. All a mocking tool does is say, give me an interface, create a virtual class that implements this interface, and follow these directions. When this method is called and the following things are sent in, return the following thing. So you don't have any true implementation code. So you can stub out. It's really all it's doing is creating all these stubs. Because now I can use mockbilling.object, mockcustomer.object, notifier, and logger.object, and that's the stub implementation of all these interfaces. And now I can instantiate my commerce class from a unit test using those stub classes, and I'm not really hitting the database. I'm not really processing a credit card. I'm not sending out any email, nor am I logging anything to a file. Make sense? I'm able to unit test the commerce process order method to unit test its proper completion without exception, without having to dive into any one of those little details. And I just made it a real cheap test. I don't ever want to hear that you guys actually do this kind of assertion, okay? That's like all the exception handling that you do, right? What is good exception handling? / to do? Come on, we've all done it. Admit it. All right. So that's what writing decoupled software is about. I've stopped instantiating things inside my class. But something's got to instantiate it. And that's where I'm still not all the way there. I'm still a little coupled because something has to instantiate it. And that something is out here. Now, it's not too bad, okay? But here's the thing. What if my commerce class, right here, all of a sudden changed the amount of dependencies that it requires? Let's say it added 2 more dependencies because the steps got longer. What would you have to change in the examples I've shown you so far? The first thing you got to change is that you got to write your other classes, you got to write your interfaces, and you got to inject them into here, right? But if you inject them into here without making any other changes, what did I just do? I just broke my code. I now have to, this is key, this sounds trivial, but this is going to become key. I now have to start backtracking what has created the commerce class, because whatever creates it has to now be adjusted to send more dependencies into it, okay? So here is where, I happen to know that this is the only place that is creating the commerce class. So I would have to add the other 2 dependencies here. Or in some cases remove, whatever I got to do. But what if there are sub-layers of dependencies? Think about that. Commerce class receives 4 dependencies. What if the billing processor happens to have a couple of dependent classes that it relies on? And sure, you can abstract those out to interfaces like you should, but now you got those interface arguments going into the constructor of the billing processor class. Now, how would I fix that problem with this kind of code? Well, the program class is what's instantiating your billing processor. So now if I add dependencies to billing processor, I got to modify this right there because that's where I'm instantiating it, right? So you got to start doing all this backtracking, and that's where it can become a real pain in the butt. Not that it's impossible, but this is why we have the aid of dependency injection products. You're starting to see the problem here? The decoupledness works out really well for testing, but in real life, having this kind of decoupledness without the aid of a container product can start to become a real nuisance once you have many layers deep of dependency injection. But what you're seeing here is dependency injection. This is why I like to tell people, a DI container doesn't help you with testing. A DI container helps you with the next problem that I'm going to show you, which is the one that I just finished describing, the creation of the classes. What helps you with testing is setting yourself up for DI container usage. And you can only do that by decoupling your components, by working with interfaces, by eliminating equal mu. Use that as your litmus test. Once in a while, you'll come across a rare situation where you have no choice but to new something up in a class. It will get rarer and rarer the more used to this kind of programming you get. Make sense so far? Yes? Yep. Yeah, absolutely. But order info is just the data class. This is order info right here. It's just carrying my data. There's no methods in it or anything. I just needed to have a bunch of data in there so that I can show you when I run it and everything's showed to the console app. You see some good data in there. You'll see my name and my email and hopefully not my credit card info. Okay, that's not my real credit card. Yeah, it's just a data class. It's the info that in a real e-commerce, this would be my entire shopping cart, right? All the products that I put in there, my customer information, my billing information, all packaged up in the data. All right. So what exactly is dependency injection now? Now that we know that we have to be abstracted, that we have to stop coupling code and stop newing up objects, how do we solve the real problem? Well, dependency injection itself is nothing more than an architectural pattern, okay? It's a design pattern. It's designed to satisfy a class dependencies. Think about that statement because that actually describes the last problem that I discussed, which is if you have one class that has dependencies, but those classes may have their own dependencies, and even those may have their own. And what's that old shampoo commercial from the 80s? And they told two friends and so on and so on. You remember that one? Am I the only old guy that remembers that commercial? So, but you can go really, really deep with dependencies, so the act of resolving them and instantiating those classes becomes harder and harder the deeper you go. This is where dependency injection, the pattern with the help of a product, comes to the rescue. It's typically implemented with the aid of a container, but I should actually remove the word typically and just capitalize the word implemented with a container, because I've never seen a situation where people have multi-layer dependencies resolved and they're not embracing the use of a dependency injection container in their product. So the DI container is a repository. At the end of the day, it's a very simple bucket of key value pairs. And in its simplest form, does nothing but associate a class to an interface. Now that's a very simple statement, but they can get a lot more complicated, and we're gonna get to those complex scenarios. But in a very simple definition, it's just a bucket of associations of a class to an interface. Now you remember I showed you billing processor, implemented iBilling processor, and the notifier implemented iNotifier. Well, I'm going to associate those two classes together in a dependency injection container. This act is known as registration. The instantiation of classes is known as resolve. So once you've associated your types in a dependency injection container, I'll show you how to resolve them. Now, associations or registration can take many shapes, and that all depends on what container you're using. The most common one that you see out there is procedural, which is the one that I'm going to use. And procedural is supported by all of them, and now it's supported by MEF 2, MEF 2.0, not MEF TOO. These are just some of the more popular dependency injection containers out there. There are others. Spring is not just a DI container. It's a larger framework that has a bunch of other stuff besides DI. But you could also do configuration. A lot of DI containers allow you to set up your associations of a class to an interface in an XML file or in a config file, and then just tell the container, go read them from there. That allows you to modify that file without having to recompile your code, of course. Another way of doing it is declaratively, through attributes, and MEF allows this. This is how MEF does what it does. MEF doesn't do procedural. MEF tells you, go to your class, like billing processor, and decorate it with an attribute called export. Give me the associated interface there, and do that with every class that I want to associate with an interface. And then when I set up my container, and you'll see how I set up in a second, you just tell MEF, go to these assemblies and discover everything. And it uses reflection to peek in there and look at the attributes and build its list that way. But the end result is the same. The end result is nothing more than a bucket of key value pairs that associate a class with an interface, and that's it. Now, your usage remains the same. So that decoupled example that I showed you with the commerce class that had those interfaces that were coming in, that doesn't change. I've done my work there. That's good. What I want to fix now is that part in the program static main where I was instantiating all those classes, because that's what gets complicated as more dependencies are added down the chain. And the chain is hierarchical, meaning you have a class with dependencies. Those dependencies may have their own dependencies, and so on and so on. And it may stop there, or it may stop over here. It literally can get way out of hand. So just imagine having to new up all that stuff. It's a pain in the butt. The DI container allows me to do that just by asking the DI container, give me this class. When you ask the DI container, give me a class, you've kicked off a process now. And it will reflect into your class, look at your constructor, and if it finds any property, any arguments of interface types, it goes back to itself, the DI container repository, and sees if you have registered those interfaces with any classes. And if it finds them, it instantiates those classes and injects them into that constructor for you. But guess what it does before it does that? Before it instantiates a class, a dependency, it looks in its constructor and sees if it has any dependencies to satisfy. And it does this recursively all the way down. So by the time you receive the class that you originally asked for, you get it in its full loaded capacity with all its dependencies resolved and all of their dependencies resolved, and so on and so on. Make sense? Let's take a look at usage on here. Now, I have a very, very simple, poor man's dependency injection container that I'm going to show you. I wrote it. I don't recommend you use it. Let's just get that straight, all right? Just because I wrote it doesn't mean it's good. It does what it does well, but all it does is simple registration, simple resolve. End of story. Nothing fancy, nothing whatsoever, okay? And if I finish with enough time, somebody remind me to tell you the Mexico story, and I'll know what that, seriously, there's a story behind this container and its usage, all right? So this container, here's my commerce class. Does this look any different to you? I did my work in the previous example. I decoupled my code. All I'm working with is interfaces here. Now let's take a look at the program file, the one that does everything, that kicks things off. Look what I'm doing. I'm instantiating a container, and I'm registering some key value pairs. That's all I'm doing. This is, in its most basic form, this is what every DI container wants you to do. Just register associations of an interface to a class. And sometimes this may have 4 items in there. Sometimes this may be several pages. It's not at all abnormal for that to be really, really long. Some containers offer organization features to help you with that, and I'm going to get to that. Yes, sir? I'm going to get to that as well. So the gentleman asked me, what happens if you have multiple implementations of an interface, right? That's going to be one of the things I'm going to cover. So bear with me. But that question comes up all the time. It's actually one of the first questions that comes up. But look what I'm doing. After I registered this, look how I'm building my order info, and now look how I'm creating my commerce class. You notice that I'm not newing anything up? All I'm doing is telling my container, create me that type. Some containers force you to register a concrete class that has no associations if you're going to incorporate it into DI resolve. Some do not. I didn't ask for that. I didn't enforce that on my container. So as you can see, I'm not registering the commerce class. But I can still tell my container, please go create me a commerce class. You're going to get all of this code. You're going to get the code, the slides, you're going to get everything, I promise you. I mean, feel free to take pictures if you want. I'll even smile for you. But all of this stuff is going to be yours, I promise. Now she's totally red. You should see her. You want to stand up and bow? All right, so by me asking for the commerce class, my container is going to go into here. It's going to see this, and it's going to say, oh, cool, you got some interface arguments. Let me go back to my repository and see if I can satisfy them. And before I satisfy them, let me reflect into them and see if they have any dependencies, and so on and so on and so on. So by the time I get this back, I get a commerce class with those 4 dependencies resolved, and I didn't have to new anything up. What if I added 2 more dependencies to my commerce class? I come into here, I add them, right in the constructor. I don't have to change a darn thing here. I don't have to start backtracking my newing up, which makes it a lot easier. Make sense? Pretty cool so far? Oh, it gets better. And it gets more complex. Don't think it's going to all be this easy. So if I run this right now, I'll run it real quickly, just to prove to you that this works. There we go. I don't know if you can read that, but there you go. There's all the console write lines that all my processing classes were doing. And in fact, I can quickly prove to you that this is fine by putting a breakpoint right here, running it again. There's my breakpoint, and check this out. Billing processor has been resolved to DI poor man's container billing processor, because that's what I registered. So all of the demos are going to output the same kind of stuff. So don't be pissed if I skip the running of some demos. It's the code that's going to be important to you guys. Any questions so far? Because we're going to take it up a notch now. Simple registration and resolve. And the resolve is recursive all the way down the line. Yes?
So how do you figure out, like, if you have a bunch of interfaces, you have to just, it takes runtime to figure out where you're at? I mean, obviously, you go back to the code, start to figure out. That sounds like it's getting messy.
Your job as a developer has not gone away, buddy. Seriously. Yeah, at some point, you got to be able to keep track of a lot of stuff. But you'd be keeping track of a lot of this stuff nonetheless, but you're doing a lot less tracking when you're using a DI container. Give me a little more detail on your specific concern, because I have some dependencies there. A lot of times I don't have to worry about where I'm at. All I have to worry about is that I'm registered properly, that I have the proper concrete classes registered against my interfaces, and that every class that I'm serving up is coming from a container.
I guess I was thinking, like, if you had like an iSaveable interface, you have different objects, and they might save in different ways, and one might have it next row somewhere else, another table, and like when you go and it saves all of them, it's going to be running a
Okay, so at that point, your concern is kind of a variation from this gentleman's question about if you have more than one implementation of a class. Let me get to that point, and if you still have that concern, ask me the question again and I'll address it, okay? But I think your concern may be addressed when I show you how to bring in multiple versions of an interface in, and then letting you somehow determine in your code which one you want to execute. If you were able to do something like that, would that help you out? Okay, so I'll show you how to bring it in, and then if you're still a little concerned, we can talk about it then or talk about it afterwards, okay? We're pressed for time, but I'm scheduled to be at the Ask the Experts between 6:30 and 8:30. So if whatever I don't resolve for you here in this room, please feel free to catch me in that 2-hour block or whatever else time we need to take, and I'll be more than happy to help you, all right? And if it goes beyond that, we can discuss hourly rates. Because I am a capitalist after all? No, but I'm more than willing to help you out. All right. Let's see what we got here. I take minutes off the presentation just if you eliminate these darn animations that I hate these things. Okay, other DI techniques. This one's an important one. This is where I'm going to get a little fancier because here I'm going to show you some patterns to help you out, okay? Now, let me discuss what this slide means without just reading the bullet points. I just showed you a class called Commerce that had 4 processor subclasses, okay? Now, I showed you one operation called process order, and that operation happened to be using all 4 of those. But would it make sense to you that that Commerce class has more than one method? Yes? Would it make sense to you that maybe one of those methods uses one of those processors and not all 4 of them? Possibly. Maybe the logger, maybe the notifier. Now, if that was the case, and I got 4 dependencies coming into a class, I've just instantiated excess classes that I wasn't going to use. And I don't care what anybody tells you, instantiation in the CLR has overhead. There's a lot of, generation tracking, garbage collecting, all that stuff, heap and stack building, and there's a lot of weight that carries with object instantiation. So if you can avoid it and do something a little more on demand, you may be better off. So I'm going to show you a pattern that's known as a service locator pattern. Does that word mean anything to anybody in here? Service locator? I'm sure you've heard that if you've opened up a pattern catalog. A variation of this pattern is also called the abstract factory. Sometimes they're interchangeable. It depends how much of a stickler you are to the rules of pattern cataloging. The abstract factory takes a generic at the class level. The service locator takes a generic at the method level. Because I don't want to get yelled at by anybody, not that I normally would care about that, I called it what it is, which is a service locator. So what I'm going to do is that I am going to give you a service locator so that you can ask for a class in the Commerce yourself. You can then instantiate whichever one of those processors you want. Now I'm going to show you 2 levels of doing this, okay? One of them is a specific service locator. The other one is a more handy generic-based service locator. But I want to walk before we run, okay? So let me show you what I mean by service locator. You see how slow that animation goes? It's ridiculous. Huh? I should have gotten rid of it, but I'm not going to worry about it now because it's just going to slow me down. Just tell me who I can yell at about that. Okay, now, the first thing I want to show you is real quick, because I'm going to be using AutoFac going forward. I want to show you AutoFac dependency injection usage, okay? Take a look at this Commerce class right here. It is 100% the same as the previous example. Exactly the same. It's called Commerce 1. I made my demos real easy to follow here, so every demo has a number, and they each have their own Commerce class. So this first example here is regular container usage. And all I want to prove to you here is that in basic container usage, the only thing that differs is the syntax. This is AutoFac. You see how AutoFac works? AutoFac works by building a container builder first that you see on line 50. Then I'm registering my types. The syntax is different. See, I'm registering one generic as another generic, but it's still an association that's taken place there. Okay? AutoFac does require you to register concrete types if you plan on resolving them, whereas my poor man's container did not. Not all of them do. Ninjak doesn't force you to do that. Castle does. Unity does not force you to do that. But when it comes to resolve, notice mine was saying create type. AutoFac is saying resolve. So it's just syntactical difference, bless you. In fact, if I show you an example of unity, which I have provided for you, and this is the only time I'm going to digress into the other containers, here's the usage of unity. Bless you. You see how it's just syntactical difference? And there's the resolve down here with the word resolve. Here is, I'll show you one more, structure map. Why keep things simple when you can use lambda to completely confuse people? Right? Seriously. Let me tell you, if you haven't gotten your head around lambda expressions, keep at it. One day you'll just have a moment of clarity. That's how it was with me. I couldn't get my head around them, but unlike women, you guys will understand them eventually, okay? I guarantee you. I guarantee you. But here, the guy that wrote structure map, a guy that actually lives in Austin, just chose this kind of syntax. But as you can see, it's just doing associations. That's it. It's just different syntax. Now, the containers will get different as you add more advanced features. But this simple example is nothing more than regular registration. Now, here I'm registering and I'm resolving commerce. But I'm bringing in all of the interfaces into commerce, and let's say I only want to use one. So I'm going to show you two types of service locators. Here's a specific service locator. What I did is that I wrote another class, and this class is called iBillingProcessor_Locator. And it is associated with the billing processor locator class. Now take a look at the billing processor locator class. This is my service locator. This class is designed to locate a billing processor, but that's all it can work with. So it's very specific. It's not general usage. So I typically don't like this, but I want to show you this example first. Now, I've written a class that just wraps the resolving of a billing processor by it saying, go out and resolve an iBilling processor. And due to the registrations, what is this going to give me? An instance of billing processor, right? And I've taken that class and I've abstracted it out. That's what makes it an abstract factory or a service locator. Because now, I still want to remain testable. I don't want to just use this class and instantiate this class in my commerce class, because now I've coupled myself again. I need to abstract that out. By making it an abstract locator or an abstract factory, I can now inject into commerce 2 the billing processor locator. Now, the other ones are not using a locator. They're just using the regular interfaces, customer processor, notification processor, etc. But the billing processor is using its locator, which means before I use it, I have to obtain a billing processor. And I do that by saying, okay, this billing processor locator is designed to get me a billing processor and return an instance of iBilling processor. So I'm getting it on demand. If I didn't want to use it, I did not need to do line 25. But I haven't really solved the problem of class instantiation because I've omitted the necessity to instantiate an iBilling processor implementation unless I need one, but I have forced an iBilling processor locator to come in, right? What if I don't want to use that at all? I still have 4 classes that are being instantiated by the dependency injection container, and I might only need 1 or 2 of them. So a general usage billing processor locator is more what I want to use, and I'll show you what that looks like. Now, I'm still registering all my classes. The registration, by the way, takes place one time on application startup. This is the kind of thing that happens in a splash screen in a desktop app, or as you'll see later in my web examples, it happens in the application start. So don't think that you're going to be running through this over and over and over again. It's a one-time shot, okay? Now, I've registered everything, but look what I've registered. I got something here called a processor locator, and it registers against an iProcessor locator interface. My resolve is still happening the same way. My process order is happening the same way. You're not going to see that change. But now let's go into that processor locator and see what it looks like. Processor locator is an implementation of iProcessor locator. And as you can see, it's not directly tied to any one of my dependent classes. As a matter of fact, it's too generic. In real world, I'd probably want to put a constraint on this, right? Maybe have a general marker interface that all my processors inherit from. So iBilling processor inherits from iProcessor, iNotifier inherits from iProcessor, and then here I can just say where T is an iProcessor, and that'll just constrain it a little more. But all I'm doing is saying, go get me T, and return it. What I've accomplished by this general purpose one is the following. And I'm looking at 3. So now look how many classes I'm bringing in. I'm bringing in 1 class. It's still an interface type, so I can still mock it on a unit test with no problem. And I can mock it on a unit test and tell the mocking tool, I can tell mockQ, when the get processor is called from that class and an iBilling processor is requested, return a mock of iBilling processor. So I got full mocking capability here. I have not lost anything that I gained by abstracting it. I've kept everything 100% testable, no exception. But here, in this method, I am using all 4 processors, so I'm instantiating all 4 of them. And as you can see, I am now returning instances of iBilling processor, iCustomer, iNotification, and iLogging by asking my service locator, please go out and find me this. Make sense? And I got 1 class that's coming into here. I use this technique religiously. If you watch, has anybody ever watched my multi-client end-to-end course, my Pluralsight one? 1 person? What's the matter with you guys? 2 people? Say what? Oh, you just have a question? Put your hand down, man. What's the matter with you? But you watched it. All right, the reason I bring it up is, I'll address your question now, is because I use this pattern religiously to do data repositories. If you remember the data repository stuff and business engines, I have a ton of data repositories, but my services may need 1 or 2. So I use this pattern to get me only what I need, and by abstracting, I'm still remaining 100% testable. Now that you've teased me, you can ask your question.
Why you like this? Because I don't.
Tell me why you don't.
Because the process locator sent in, it forces a precondition. You have to memorize that those 4 classes have to be instantiated before you call. Instead, the other way, it was very clear that you're passing those 4 things in.
Yeah. Well, I'm going to be writing this code, correct? If I'm going to be writing this code, I know I'm going to need that, and I know I'm going to need that, and that, and that, which is going to trigger something in my mind saying, don't forget to do this, or I'm SOL.
You're saying you have to memorize.
Well, memorize what? What are you concerned about memorizing?
When you pass it on to the guy who has to maintain it, he's got to derive that at some point.
No, I don't disagree. I don't understand what it is that you're trying to, that you think that you have to memorize.
That those 4 objects, I find it much clearer to pass them in. Then I know.
Okay.
When I'm passing it in, what I have, what I've got.
Okay, that's perfectly fine. At this point, I may not agree with your concern, but it's a concern to you, and that's all that's important, right? So at the end of the day, if you like the other pattern better, I feel pretty comfortable telling you that you're probably not going to get a real performance hit with instantiating all of those unnecessarily, but if they ever grow to a longer list, you may. Uh-oh. All right. You know what? We can continue conversing about this later. I totally understand your concern. Even though I may not agree with it, I understand it's a concern to you. So, how much of a psychologist do I sound like now, huh? Tell me what you really feel like. All right. Service locator. Make sense to everybody so far? Let's take it up a notch. Let's see what else we got here. You guys having fun at least?
Yes.
All right. There goes that slow. Everybody, I'm just going to move with the animation. There we go. Okay. Here's an important one, right, Patrick? This is a very important one. This is one of those that, to me, I've learned after understanding this, and I got to give credit where credit is due. It took a customer of mine, the gentleman in the second row there, to bring this to my attention and to make it a true item of concern, and because it did bite us in the butt, and we fixed it. And it's a fixable problem, but you have to know about it because it's more of an unknown problem than what people think, okay? Instance lifetime. You got 2 primary instance lifetimes given by every container. You got transient and you got singleton. Most people that have used DI containers know about this. Transient is the default for most containers with the exception of MEF. MEF defaults to singleton. And the resolved instance is kept until its parent chain goes away. So in my case, how long is the instance of billing processor kept around? Until commerce dies. And when does commerce die? In my case, when program static main dies. It depends on your application, right? But you, more often than not, I'm willing to say, you don't have a lot to worry about when it comes to instances lingering in memory. Because all you've done is you've delegated the creation of these to a container instead of you having to do it. But either way, you're going to need an instance. Singleton is a shared instance. Now, this has very specific usage, and I'm going to demo it now. This is kept around until the container goes away. So when you register an item as singleton, the container will always feed you that same instance of the object once it creates it. And I'm going to demo that to you so you'll see it with a counter, okay? Now, this is the big one. Disposable components. Anybody here make it a habit of implementing iDisposable in anything they do for whatever your reasons are? We won't get into that. Okay, so it happens. As you can see, it definitely happens. Who uses WCF here? Okay, did you guys know that proxy classes are disposable components? Because they inherit from client base. Client base is a disposable component. Why? Because there's a lot of unmanaged stuff going on in there, so it's got to be disposed properly. Now, proxy classes in WCF are an implementation of a service contract. Now, if they're an implementation of a service contract, guess what? They're set up for DI usage already. They're a perfect candidate for DI usage, which means you can actually inject a service contract in WCF into an MVC controller, into any class you want, into a view model in a WPF application, and the container, if you've registered your proxy class to the service contract, the container will resolve your proxy class for you. But here's the problem. The proxy class, or any other component that you write that implements iDisposable, is a component that needs to properly be disposed. And since the container has no way of knowing when you have actually called dispose, or even if you're going to, it holds on to the instance of that class. And until the container is disposed, it doesn't let go of it. This can cause a problem in certain contexts. A very specific context is a web context, because the web context, the global ASAX stays in memory. It's application-wide, which means if you've injected a WCF proxy into a controller, an MVC controller, used it to generate a view of some kind with some data, and then the request is done, somebody else comes in, does the same thing, another person comes in and does the same thing, all of those proxy classes, even if you've gone out of your way to dispose them, the container will hold on to the instance. And until the app goes down, which is not going to happen unless somebody brings down the IIS, the website, the container is not going to dispose. And until the container disposes, those classes are not going to be released. So eventually, it can cause a memory leak. Well, it is a memory leak. Eventually, it will cause a problem. So instancing becomes a very important topic in certain contexts. And I'm going to show you how to solve it. Now, some containers offer help for this. AutoFac, in my opinion, offers the best help. I've already researched what the containers offer with this, and none of them have made it as crystal clear as AutoFac does. Because it all involves a subcontainer hack, creating a subcontainer from your container so you can resolve your instance from that subcontainer and then dispose of it. But to do all that manually, I don't even want to get into it. It's a pain in the butt. I mean, the article that you forwarded to me, I know somebody did this with MEF, was like 2 pages long. It really is the definition of what they call a hack. But the guys that wrote AutoFac thought about this, and they made things a little easier for us, so we can do this with AutoFac in a much, much easier way. And I'm going to show you that way now. Now, first of all, let's do singleton real quick. See this single tester right here? Let's go into Commerce 4, and I'm going to show you single tester is going to display a counter. So I am going to run demo 4. Oops. What is this? I'm going to run demo 4. And as you can see, you see that counter right there? It says 1. I'm going to run it again now. The counter is set to 1. It's a different instance. Okay? Now, what I'm going to do is that I'm going to change this real quick. I'm going to show you how in AutoFac you register a singleton. And that is like this. At registration time, you tell it, when I register single tester and I associate it to the iSingleTester interface, make it a singleton. So any class that I have that has this interface injected into it as an argument is going to get an instance from the container, but because I'm registered this way, they're going to get the same instance over and over again. So if I run this demo again, I want you to look at what happens. The counter is 1, and if I hit it again, the counter now increases because it's the exact same instance. It was kept around in memory. Even though I got a different commerce. Oops. See, I'm resolving it once, and I'm saying enter the process again, and I'm grabbing another instance of commerce 4. So I'm grabbing commerce 4 all over again from the container. But commerce 4 is registered as a transient, whereas single tester is registered as a singleton. That's why you saw the counter increase. Okay? Now, as far as scope resolving, AutoFact lets you do things kind of interesting. You see how I'm doing container.resolve here? If you have disposable components, you can do this. AutoFact lets you do a resolve. See how I'm resolving commerce 4 on line 119? But I'm not resolving it from the container. What I did is that I created a subcontainer. This is a feature of AutoFact that lets you create a lifetime scope instance. And off that scope is where I'm doing the resolve. But then when that scope goes out of view, and I said I did it in a using statement, it's going to dispose that scope, it'll dispose anything that it held on to. Now, the problem with this technique is that you now have to write code like this inside the classes that are going to ask for your dependencies. So imagine having code like this inside the commerce class. That almost breaks the abstraction and the testability that I want to portray here. Yes? Say again? No, the singleton will exist because it was told to exist, because it's specifically a singleton. But if, and I wish I would have come up with a better demo, but if building processor was an implementer of iDisposable, it will be held on. Now here's the thing, it's not held on to by the container as a singleton. You're still getting another instance next time you use it, right? But the old one is just going to be held in memory. So it doesn't cause your component to become a singleton at all. It causes your component to just stay in memory. And memory is finite, so eventually it's going to blow up. So that's the problem here. But this solution for the problem, in my opinion, is not enough. It gets us almost there because it solves the problem of disposability, but it breaks encapsulation because now we have to write this code inside whatever component is going to use a dependent component. So what I want to do is that I want to do something a little cooler. I want to have this encapsulated into a service locator. So I'm going to take that service locator pattern that I showed you earlier, and I am going to take it to another level. Take a look at this class here, processor locator. Now, the original processor locator did this. Remember this? Let's take a look at the new processor locator. It implements iProcessor locator, and look what it's doing in the constructor. It's calling the create scope method. And what's create scope method? It's creating that scope. And all I'm doing is that I'm letting it create a scope inside of itself so that now when I call get processor, my resolves are coming off that scope. And the key here is that I have a method available to me now, which is also abstracted to the interface, to release the scope. And this allows me to clean up my code a little bit in the commerce class. So if I go to my commerce class, notice that I'm bringing in iProcessor locator 2 here, and I'm requesting my 4 processor classes, no different than I did before. But if they happen to be implementers of the iDisposable pattern, I want to ensure they're not left in memory. So now I have a place here where I can call release scope from my processor locator, and that will kill that scope instance, because AutoFact gives me the ability to create a sub-scope instance real easy. And because it's all abstracted, when I go to mock this class out in a unit test, I can mock out what release scope does and just tell it don't do anything. So it won't break this. Does that make sense? This is probably the more complex thing I'm going to show you tonight. Yes?
What if you were to dispose of that?
Which one?
The processor locator.
Dispose it where?
Yes, on that.
Okay, well, the processor locator came into here. So as long as I don't dispose it or release the scope until I'm completely done with its usage, I'm going to be just fine. Because the next time that I come into commerce, I'm going to get a new processor locator. And processor locator itself was not a disposable, so it's not going to stay around in memory. Yes?
Should the release scope be in like a try finally or some kind of pattern so that you accept
Sure. I mean, in the real world, I think a lot of this stuff would probably be in try catch, at least with a // to do.
you call the process locator, you're calling it with no arguments. What if you need to pass an integer or a string or whatever?
To do what with?
Everything has to be, a constructor with pure interfaces.
No, you can, in most of your IC containers, you can add constructor arguments. So if you
Yep.
you need to pass in extra string or some other.
I'm actually going to show that. Yeah, I'm going to show that. This is a feature, a more advanced feature of containers where you can register a component and say when you see, because here you got a public constructor with 4 interfaces. But you're right. What if one of those things was a string? What do I do there? Well, when you register, you can tell it if you run across this argument, put this in it. Make sense? And I'm going to show you an example of that. Yeah. That's the problem I'm trying to solve. I don't want to hold on to it. The minute I implement disposable on processor locator, the container is going to hold on to it, and I don't want it to do that. Exactly right. Exactly right. It's a rare problem because it's only applicable when you have disposable components, but if you're a WCF user, disposable components are a way of life for us. So it becomes a real problem. And as a matter of fact, the test that you guys ran clearly showed the memory leak, correct? Okay, let's go to the next thing. 13 minutes left. I think we can do this. Okay, let's go to advanced registration feature. These vary from container to container. Sometimes listing out all your registrations one by one by one by one just gets to be a headache. It's too monotonous. It's easy to miss one. What if you have a lot of classes that end with the word locator and you start adding 5 more, 6 more, 10 more, 20 more? You got to remember to come back and register these things, right? And if you don't register them to their interfaces, they're not going to resolve. But if there's an area of commonality with each of these classes, you can use your container's Fluent API to help you out. And this is going to vary from container to container. But let me show you what I mean by that. AutoFac has the ability to do assembly scanning. So here, I'm registering Commerce 5 by itself, but here I'm registering those 4 processor classes. But look how I'm doing it. I'm saying go out to this executing assembly and register where the class ends with the word processor as the interface of I with that name. It's just some fancy Lambda usage that's there. So now I can add however many classes that end with the word processor in both their name and their associated interface, and I don't have to worry about coming back here to register them because this Fluent API helps me out. You understand? And if all those classes were in another assembly, I don't even have to put this code here. I can write a module in AutoFac to offload it to another class. And here's module usage. Look what this looks like. This is the exact same thing. But instead of saying register all those, look what I'm doing. I'm saying register module. And what's this register module? Processor registration module. It's a class that implements AutoFac module, and in its load override, it's got the registration because it receives the builder. So if I have a bunch of these registrations and I wanted to group them into more organizable classes, I can write these separate modules. And other containers have these features too. I chose one to demo it. But this kind of stuff is not completely indigenous just to AutoFac. In fact, AutoFac leverages this module usage to do its configuration stuff. It's got a built-in module that actually goes out to the config file and looks for registration information there and just does all the procedural stuff based on information that it finds in the config file. So the end result is going to be exactly the same. Exactly 100% the same. Instead of listing all my processors here in registration, I just do it with one line of code. This is actually one line of code. I just broke it out so you can see it. But now I can add as many as I want. As long as they fit this link query, they'll be found and they'll be registered. So having conventions in your program is more important than ever. That's something that I always recommend anyway. But now when you're dealing with something like this, what would happen if I didn't follow this processor suffix convention? This would completely fall apart. Would it fail my application? Not if I'm willing to register one at a time, but it just keeps it a lot cleaner. And the execution, like I said, it's exactly the same. Okay, let's do this one. One-to-many registration. Sometimes you need to register more than one class to an interface, okay? A less common approach is to label, and I don't have a demo for that because I'm already pressed for time, where you register, let's say you have an interface called iPlugin, and you have a bunch of different plugin classes. Now, a less common usage is for you to register class A to iPlugin, class B to iPlugin, class C to iPlugin, and name them. You can add a name, an actual string identifier that you can use later during resolve. Get me the following one, the one that's called Miguel, or the one that's called C5, or something like that. That can, and that may be something like what, there was a gentleman that asked me a question about that earlier, around here. That may be what you're looking for, and we can take it offline and talk about it more later. The demo that I have is the most common usage of one-to-many registrations, and that is when you have a group of classes that implement an interface and you want to bring them all in to a list. Once you have them in a list, you can now decide which one you want to execute, or you may want to execute all of them, which is what I'm doing. But once you have that list, you're on your own to do with it what you want to do. Let me show you what I mean by that. Here's the plugin. There's an interface called Do Something, and all I have is a bunch of classes that implement that interface. I have 3 actually, and they just tell you plugin 1, 2, and 3 have been executed. To register them is no different than any registration you've seen. As a matter of fact, I've mixed and matched here. I'm using simple registration for my processor classes and my locator, and I'm using the assembly, register assembly types to find all the classes that start with the word plugin, and I'm going to register them as iPostOrder plugin. You see that? Now, how do I use this? Well, when I go to resolve Commerce 7, look what Commerce 7 looks like now. There's my processor locator, and there's my plugins. You see what the difference is? I'm not bringing in an interface, I'm bringing in a list of interfaces, an IEnumerable. When the container sees that, it will resolve all the classes that implement that interface and give it to you in this list. And then from there, you can do whatever you want with them. In my case, I'm just looping through and calling do something on all of them. This is a very common way of doing plugin type scenarios. Because now if I run this, you'll see at the end, plugin 3, 2, and 1 were executed. Can you control the order here? It's entirely up to you. I wouldn't depend on the container doing an order. Because remember the way I registered them? I just said go out to the assembly and find them. So it all depends on what reflection is doing at this time of the day. It just happened to be 3, 2, 1. Make sense? Yes, sir.
What happens if you have a class that has, say, 10 interfaces?
A class that has 10 interfaces. Well, if you have a class that has 10 interfaces, you register the class to an interface, you register that class to another interface, register that class to another interface. At the host level, you're going to be dealing with interfaces. So all you end up with is the container resolving the same class for these different interfaces. I think it will. Yeah, I think it will. It will instantiate it 10 times. And then in each of the arguments that it resolves for you, you will only have access to the members that were defined in that appropriate interface. But yeah, it would make sense to me that it instantiates it multiple times. So class design, we still need to do a little bit of work. We still need to design our classes properly. You know what I mean? You can, but then you're opening up another can of worms. Just understand what you're getting into with singletons. Who said that? Absolutely. Absolutely.
For that piece of per resolve, lifetime manager is similar to a singleton, but it is shared just between the object graph.
Okay. That pattern I haven't used actually. Yeah, this is a perfect example where there's more than one route to solving your problem. We're not in any danger of losing our jobs. Believe me. Okay, let's talk about this one last topic before I show you some scenarios, and I got just over 5 minutes left, okay? Post-construction resolve. Post-construction resolve is rarer now than it was before. It was more useful before. What this allows you to do is skip registration and kick off a resolve process after a class is instantiated, which means you don't want something else to control the instantiation. This was useful when something else needed to instantiate the class for us. I bring back the example of WCF. In WCF, it's the WCF runtime, the host, that is in charge of instantiating a class for us. When somebody wants to call our service, WCF needs to be the one to serve up a class. Yet, I just taught you that in DI usage, we need the container to serve up a class. So now there's kind of a battle of wills there, right? Both of them want to instantiate a class for us. So the way that I used to do WCF DI is that I used to inject my stuff into WCF using property injection. Property injection is no different than constructor injection, except you're declaring your dependencies as public properties. Then I can tell the class within itself, kick off a registration process, which means when somebody instantiates you, whether it's one of you guys with a new statement or WCF instantiating a service for me, when you run the default constructor, in there you're going to see a line of code that's going to kick off the resolve process. Let me show you what I mean by that. Now, there's a better way of doing it now. Bless you. So in Commerce 8, is this it? Yep. Okay, so in Commerce 8, notice I have this, and I have some public properties. I don't have any constructor arguments. Why? Because something else is going to instantiate this class for me. I don't know what that something is. In the case of WCF, it would be WCF runtime. In my example here, I'm going to do it using a good old-fashioned new Commerce 8, which means I'm not incorporating dependency injection into the resolving of Commerce 8. So I'm delegating the process, the task of doing it to Commerce 8 itself. And I'm telling it, okay, when you finally get newed up, go ahead and kick off the resolve process. And this is what kicks off that recursive resolve process, where it goes in, finds these properties, and then resolves them from the dependency injection container. Now, this is a very doable solution, but it's also a much uglier solution because it's coupled you to this, which is probably something that we don't want to have. So this problem has been solved already, like this. Now, first of all, I'm going to show you how the problem has been resolved in a couple of minutes with a usage example. But notice here, I am asking the container for Commerce 8. This is just to demonstrate that property injection still works. So I can choose to do property injection instead of constructor injection if I don't want to touch the constructor. And when I run this, it's going to inject these because I asked the container, please go resolve Commerce 8. So it's going to inject them. And then I use them just like I did in my previous examples. Now, how this problem is solved in cases like WCF, I'm going to show you in just a few minutes. There's one last example that I need to show you, and I'm really pushing it on time here. When's the next speaker go on? Half an hour? If we take like an extra 5 minutes, will you guys stick around? I told you I had a lot of stuff to show you, and I tend to go overboard. A lot of times I give you more demo than what I have time for, just because, you know, I'm cool like that. Let me show you Commerce 9. Commerce 9 is another common example, and in fact, me and my client had this example, okay? And I didn't know AutoFact can do this until recently. Now, Commerce 9 has a constructor that happens to have the two injectable dependencies, right? It also has another constructor here that's got 4 variables in it. Now, every container chooses what constructor they want in their own way. One container may say, I'm going to choose the first constructor that I find. One container may say, I want you to tell me which constructor to use by its order number or whatever. AutoFact, and as a matter of fact, Unity as well, will choose the constructor with the most arguments. Now, which is the constructor with the most arguments? You see the problem? Now, if I run this right now, I just told it here, register commerce. When it finds these parameters, just send the number 1 into it, and that answers one of your questions, okay? And I'm going to register my processors, register my plugins, and so on, right? Then I'm going to go ahead and run it. But what's going to happen here? Hit 9. What constructor got called? the one with the most arguments. Did any of my dependencies get resolved? Nope. So what happens next? A mushroom cloud. As you can see, it just blew up here because iBuilding processor is set to null. So how do I solve this problem? Well, every container has its own way of doing it. AutoFac has something really nice that lets you do, which is what I'm going to show you now. This is the same registration, but I wrote something called a constructor finder. In fact, it's so damn awesome that I put the word awesome right in the title. Now, a constructor finder, as you can see, the code is exactly the same, but I told it, use the following constructor finder. A constructor finder is a class that I wrote that implements the iConstructorFinder interface. And all of the constructors of the class that it's going to resolve will be sent into here. Okay? I'm sorry. Nope. The find constructors is going to return a constructor info. But the type that I'm going to resolve gets sent into here. So now it's up to me to do something with that type to determine what constructor I want to use. You understand? You can do whatever you want. I chose to go a cool route. I'm choosing to have a custom attribute that I wrote called awesome constructor, and then I'm going to loop through all the constructors of that class, of whatever that type is, and if I find a constructor decorated with the awesome constructor attribute, that's the one that I'm going to return. Because now my commerce 9 has awesome constructor on there. And when I use my constructor finder and I hit 9, now as you can see, it broke out there. It's whatever the reflection, it's the performance you get with any kind of reflection usage. Who's asking that question? I can't see. Reflection usage always has its performance. It's one of those things where you got to weigh out, do you get enough return on investment to use it?
So that raises the question of the underlying containers. We do a lot of this on our own with reflection, with XML. What is AutoFac? They've got to be doing something with reflection.
Tons of it. Don't think for a second that reflection is not taking place. There's tons of reflection. It by no means is a performance benefit, but in my opinion, you get such a tremendous return on your investment that reflection becomes negligible. It's one of those things where you're willing to do an extra blink of an eye to wait for something. You know what I mean? But there's always going to be some kind of hit with reflection. So the rest of the demos, I don't want to go too much over, but let me show you what I got in the rest of the demos, because I'm afraid that you may have to go through them on your own. We finished all of this stuff. All I have left is usage scenarios. And there's 4 usage scenarios that I prepared for you, and the demos are really easy to follow. I prepared one in WPF where I resolve view model classes. Not only do I have a main view model class that has 2 sub-view models, those view models are injected in, but those view models have a service class that they're using to go out and get data. So it's a 2-level recursion process. And by me asking for that one view model, I get everything automatically. That's the WPF example. The ASP.NET MVC example, which also applies to Web API, will show you how I can inject into the constructor of a controller some dependencies and how I hook that up. The web form one uses a custom page handler factory to show you how I can do that. And the WCF uses something called an instance provider, which AutoFac will give you a service behavior to automatically install it. Do you guys want to, I'm not going to force anybody to stay, but it'll only take me less than 5 minutes to go through it real quick if you want to see it. So I'm going to take it by the people that are sitting down and really want to see it. Okay, so here's my usage scenarios. And by the way, I've given you usage scenarios in MEF and AutoFac. So here's the WPF one. Here's my main window view model. And my main window view model, and I went one step further. I want to make view models fully testable. So I did something that a lot of people don't do. I abstracted view models out to an interface of their own. So main window view model has an iMain window view model. And as you can see, it receives these 2 other view models in the constructor through interfaces. And those view models receive an iCustomer repository through an interface. So once I have those chains set up, When I go to instantiate the first one, the top one, which is main window view model, I just simply ask the container for it. And by asking the container for it, I get everything all the way down the line. And when I run it, you'll see that I have my customer list view and my view here, and they're getting all their data perfectly fine because I got everything that I want through dependency injection. And it's in the app XAML.cs that I'm doing all my container setup. That's the WPF example. The MVC example. The controller, a regular MVC controller, receives iCustomer repository in the constructor. And it uses it right here to obtain information, to obtain the data. Where is it being instantiated? Well, iCustomer repository was registered against the customer repository, and it's in the global ASAX, in the application start, that I'm building my information. There's my customer repository being registered against iCustomer repository, and then here's all my controllers being registered using the assembly technique that I showed you in AutoFac. Now, once I got that container, I have to tell MVC, I want you to resolve all my controllers using AutoFac. So you do that with MVC's dependency resolver. You say dependency resolver.setResolver, and here, this comes from a NuGet package. So that's one cool thing about containers today is not only do you get any container from NuGet, but you get all the integration packages too. So AutoFac, as well as Unity and Castle and all those, have MVC integration package or Web Forms integration package or WPF integration package and so on. So this class, I didn't even have to write this class. And this class, guess what? Uses instance lifetime scope. So it takes care of the disposable problem that I told you about. And once I set my dependency resolver, all I do is use dependencies in my controllers. I just keep adding them to the constructor here if I want to use them. I don't need to worry about where they're coming from as long as they're properly registered. When I go ahead and run this, there's the list of customers, and here's one customer. Web Forms, a little different, because Web Forms is one of those situations that I talked about at the end, where the class that renders the web page needs to be created by Microsoft. Microsoft wrote this page handler factory that's part of the ASP.NET pipeline, and it has to be the class to create the form. You know how all your code behinds inherit from page? All of that needs to be assembled properly. So you can't have a container go in and say, I want to be the one to create this. You have to let Microsoft do what it does well with web forms. So I'm using post-constructor resolve. In web forms, look at my code behind pages. Notice I don't have a constructor here because it's not a container that's going to give me this class. So I let it use the default constructor, but I am declaring my iCustomer repository as a public property because it's using post-construction resolve. Now, I have to write this custom class called a page handler factory. I can inherit from the Microsoft one because it does what it does so well. I just go out and let it build the page the way it always has in the past. But now, before I return the page, I'm going to go ahead and get my container, which I've stored in an application variable, and I'm going to use that inject properties technique that I showed you. And that's going to kick off the resolve process with all those public properties. And that's how I'm able to get dependency injection into a web form. It doesn't solve the problem of the lack of testability in web forms. That's still a problem. But at least it gives you the ability to do dependency injection in web forms. And the last one is WCF. In WCF, once again, I'm depending on a NuGet package here called AutoFac WCF integration package. And every container has its own. And I wrote a service, and this service, which is right here, implements the iSample service contract. And in the operation, I'm just calling upon dependency.showToConsole. And look where dependency is coming from. It's coming from a constructor injection argument. And in the program, I'm building my container. I'm instantiating a service host. I did this all in one program. Obviously, you'd have two things in the real world, right? A client and a server. But I did it all in one. I instantiate my service host, and then I'm adding to my service host the add dependency injection behavior. You have to do this for every host you spin up. And this automatically replaces the WCF's default, instance provider, which is the class that instantiates a service for you. It replaces it, so now instead of instantiating a service, it goes out to the container to get it. And by going out to the container to get it, it resolves all the dependencies. Give me 1 second. And then right after I open the host, I'm going to go ahead and create a proxy. I just use the channel factory to be quick about it, and I'm calling perform operation. And when I run it, you'll see the dependency showing off to the console, even though I never instantiated that dependency. All I did was call a proxy, which called a service that was hosted inside a WCF host. Somebody raise their hand.
So then you're relying on the consumer of your service to do this properly?
No, this here, that's the consumer of my service right there. That's it. I just happen to put it all in one. If I had more time, I would have done it in two. But that's the consumer of my service. That's the proxy creation and the proxy call. Everything else here is the server side. Everything is the server side. And when I run it, oops. Where is it? WCF. When I run it, the host is running. As you can see, it says this text was outputted from the dependency component. So all I did was call this service right here. This service is calling the dependency show to console. Dependency came in through the constructor, and it's that dependency that is giving me that text. Say what? It takes a little trickery because you got to create, so he just asked, can we do the same thing if you host with IIS? First and foremost, I want to get out of the way, I'm not a big fan of IIS hosting, but that's a totally other topic of discussion. But you can do it using something called a host factory, a service host factory, that you can, in IIS, you can use a host factory to tap into the host instance. Because normally you don't have access to the host instance. But if you use a host factory, you now have access to the host instance that IIS is creating for you, and then you can add your dependency behavior there. Make sense? Anyway, guys, I'm really glad you stuck around. The rest of the slides are just kind of a conclusion, but I hope you had fun. Welcome, everybody. Enjoying Houston so far? Yeah. This is in the hot season. The hot season is, it's bad. It's really bad here. It's like New Orleans hot. Have you ever been to New Orleans? I was the guy in Bourbon Street last year during Tech Ed walking down the street with a gym towel on his back, just wiping my face every couple of minutes. But thanks for coming in. We're going to talk about a topic that should be mainstream, and proof of the size of the crowd in here. But judging by the size of the crowd, it's still not mainstream, and it definitely should be, which is one of the reasons I continue to talk about it. That, and it's a very, very cool topic, dependency injection. I do want to call this quick poll real quick. Who in here uses DI on a regular basis, like in mainstream app development? See, not that many. There's quite a few hands, but they're really, really scattered. Who would like to? No, it's supposed to be everybody. Because if it's not everybody, then what are you doing in here, right? It's got to be everybody. And I want everybody to raise their hands. Just every single person in the room. And just wave it. All right, now we establish that they work. So if I ask a question, you should be able to raise your hands, right? Now, judging by the laughter, I can tell your vocal cords work as well. They got mics set up here for questions. I think the room is small enough where if you yell loud enough, you may not need to get up. But I don't wait till the end of the talk to take Q&A. So if you have a question, just raise your hands and stop me. I'll use my best judgment to guide the length of time that I spend on a question, okay? So we're here to talk about DI and the concepts behind it. And it's these concepts that allow us to do the second part of this title, which is writing decoupled quality and testable software. So has anybody seen any of my sessions before? And you're back for more torture, huh? All right. Have I insulted anybody in this room before? Because I usually make it a point to do that in every single conference I speak, whether I think about it or not. So I'll try my best not to. So I've been doing this for a while. I've been on the conference circuit for a number of years now. I've been in the IT business since 1979. So I'm one of the old farts in the business. And I also got a couple of Pluralsight courses out there. I'm not here to spend a lot of time on them, but they're on my slide. So if you have a Pluralsight subscription, I encourage you to get out there and watch the course. I think you'll enjoy it, and I've gotten some really good feedback from it. So this is what we're going to do. We're going to talk about the stuff that gets us to DI usage, because anytime that I bring up the topic DI in front of a crowd, your brain immediately switches into product mode, and product meaning container, because nobody really uses DI without a container. Even though the concepts of DI have nothing to do with a container, we're going to spend a lot of time on container usage because that's what mainstream DI is all about. But before I can introduce any kind of container product, I have to introduce what these concepts are, because there were a number of people in the room that have not used DI before. And I need to talk about dependencies and coupling and what this is and why it's not good, and do the true database access, the true credit card processing, the true logging and email notification. At test time, I have a choice of either sending test implementations of these classes or using a mocking tool. Now, a mocking tool is essentially using test implementations of interfaces. It's just letting you set it up using a mocking API instead of physically writing classes. Who's used a mocking tool before? Quite a few people. All right, so this should not be strange to you. Anybody use MockQ? This is the one that I use. What about RhinoMox? Just Mock from Telerik? What else is there? What? Fake It Easy. That's the name of a product, Fake It Easy? I would use that just because of the coolness of the name. That is great. And then Microsoft's got something that I haven't used yet called Fakes, I think. And I don't know if that's an actual mocking tool or not, but it's in that same arena, if I'm not mistaken. But I can't. It's like Just Mock? Now, all of these mocking tools do the same kind of thing. They just have, it's like a DI container. You got to pick which one you like better, which one has the syntax that you actually like. All right. So let's go over to a couple of examples. Now, the demos that I have for you, I'm going to warn you, the running of the demo is actually very, very boring. They all come out with the exact same output. So I'm not here to show you a lot of output to the console because all the demos look the same. What's important is the code behind the scenes. I'm going to, and I also provide a lot more code than what I have time to show you. So let me show you the example of this coupleness that I'm talking about. I got different classes here. Take a look at this billing processor. This billing processor is a class, no interface involved. So this is the bad way. This is the before here, right? So it's a class called billing processor that's got a method called process payment, and this method receives the information necessary to process a credit card. Obviously, for all my demos, all I'm doing is writing out to the console to show you that something has taken place. But in a real application, this will go out and go to some payment gateway, like PayPal or CyberSource or Authorize.net, and actually process a credit card. I can test it for you. Does anybody have a credit card I can borrow real quick? No? That's that old comedian's joke, throw me $1 or throw me a $20 bill type of thing. All right, so I got different processor classes. Here's the customer class where it's going to update the customer order, and it's just writing out to the console. And then I got my other one. I'm going to show you all four because you're going to see these over and over again through the rest of the hour. I have a logging class that would probably use some kind of tool, maybe Log4Net or the logging application block from Microsoft. Just write out to some kind of log file. And then the notifier will actually send out an email. So all of these classes do what they do very well. They work together in the overall scheme of processing an order, but they do a very specific thing. But what they do is something that doesn't make a lot of sense that in a unit test you repeat over and over again. Think of having the unit test, this class right here, real word. There goes the English language for you, right? So you should be able to run a unit test over and over again without it causing any harm. And if your unit test is updating the database, that can cause some damage. And at that point, it's not really a unit test. It's more of an integration test. Even worse with something like processing a credit card. So we don't want to have these concrete implementations embedded into our hosting class. And in my case, it would be the commerce class. So what's the secret to all of this? What's the secret to embracing abstractions? It comes down to one very simple rule. In my case, 99.9% of the time, I can follow this rule. Now, the reason I leave you that 0.1% of leeway is because this is software, and you can't have 100% absolutes in software. I don't care what anybody tells you. The words never and always just simply don't apply in our business. There's always going to be an exception case where you're going to have to get the job done, and you're going to have to break some kind of rule. But think of it as the fat intake in diet, right? A lot of dietitians will tell you, shoot for 0, and what you end up getting is usually enough fat. Same thing with this. Shoot for following this rule. Now, this is the shock and awe part, because this is where I tell people, stop newing up objects in a class, and 50% of the people immediately get taken back, because it's a tough thing to ask. How many of you in this room have something equals new something else somewhere in a class method that they write today? You see what I mean? Do you think you can do without it? It sounds like it's a very difficult thing to do, but that's why you're sitting in this room. But if you can take this one simple rule and figure out a solution to it, you've embraced complete abstraction. You've embraced complete decoupledness. And you do this through dependency injection. And you assist your dependency injection needs through the help of a container, a dependency injection container. So what you do is you define your dependencies as interfaces. In the world of DI, gone are those days where you only use interfaces when you think you're going to have multiple implementations of one definition. In modern applications that embrace the concept of abstraction, the concept of decoupledness, I'm sure you've heard the term decoupledness quite a bit, every class is abstracted to an interface. And it's always interfaces that classes use to communicate with each other. Okay? So everything that I will write going forward is also defined as an interface. And what happens is the hosting class, in my case it's that commerce class that I have yet to introduce you to, will receive the dependent classes for the processing of billing, the notification, the logging, all that stuff. It will receive them as interface types. And what this is going to allow me to do is that it's going to allow me to send multiple implementations of these interfaces at different points in time. My two primary points in time are production and QA. So in production, I have production versions of these interface implementations that are going to, why getting away from it will facilitate testing. And after I've done that, then we're going to jump into true dependency injection, what the concept of dependency injection is and what the action of it is. What are the things involved in using dependency injection? And then how to use a product to help you out. Because once I've taught you how to do it and how these concepts of abstracted software work, doing it without the help of a container product is almost a waste of time, because we're all out to be as productive as possible. And one of the whole reasons for doing DI is to not only become testable and writing quality code, but also to be as productive as possible in writing code in a much faster way, making your deliverables come across a lot faster. And you do that with the help of a container. I'm going to discuss several containers, but I'm going to focus, I have to pick one, because I can't sit here in 75 minutes and talk about 7 or 8 different containers on how to do everything in each container. Each container merits its own 2-hour session, to be honest with you. I'm going to choose AutoFac, just because it's the one that I use. It's the one that I think it's the more modern container. It has the richest API. Anybody use AutoFac in here? Well, you guys. That's my team right there. We work together, so that's why they use AutoFac. But who uses Unity? Okay, Unity's a good container too. What about Castle? Ninject? Structure map? Okay, get ready for this one. What about MEF? I do too. MEF's a good container. It just has little drawbacks, and I'm going to discuss some of them. So after we talk about container usage, I'm going to go through a lot of stuff of container usage. I have a lot of information to impart to you. Not just basic container usage, but a lot of techniques, patterns, and tips and tricks, because there's some little things that'll bite you in the ass when you're using dependency injection that you got to know about, and there's always a way around them. You just got to know how to get around them. And the thing is, every container has its own way of solving the different problems. So I'm going to show you primarily the AutoFac way, but I will tell you every container has a way of doing everything that I'm going to show you. Some just have a little more limitation than others, and some use different syntax than others. And after I'm done with all of my usage examples, my usage demos, of which I have 9, I have a quick usage scenario set of demos where I actually have set up 4 applications. One is in WPF, one is in ASP.NET MVC, one's in ASP.NET Web Forms, and one's in WCF. And I'm going to show you real-world usage scenarios in all 4 of these things. Now, real quick show of hands, WPF, XAML. Let's just say XAML people. All right, you guys know WPF is back, right? Like a rising force. WPF is awesome. It's my favorite technology, so I'm a big WPF guy. What about ASP.NET MVC? Okay, what about ASP.NET Web Forms? Excellent. Good to see that Web Forms is still alive. Great technology also. I'm going to show you how to use DI with Web Forms, in case you've heard the rumors about it not being possible. What about WCF? And no, Web API has not replaced WCF. But the MVC demos that I'm going to show you apply to Web API as well, so WCF merits its own set of demos. And I stuck those in there at the last moment, which is why I sent you updated code like 2 or 3 days ago, Cesar, because at the last moment I just wanted to put more in there. So here's the shock and awe statement, okay? You notice I say breaking a lifelong habit, and this is where I tell people a certain rule of thumb that I'm going to ask you to go by that's going to take some people by surprise, and others it's going to make sense to you, but I'll explain it either way. So what coupling, what class coupling is all about is very, very simple. Most everybody in this room probably understands this, so I'm not going to spend a whole lot of time on it. It's all about one class depending on another, and a lot of times this is all embedded in the code, which means a class cannot compile without the existence of another. So let me set real quickly the case study example that I'm going to use throughout the entire 75 minutes, and that's a simple commerce class that's going to process an order coming in from a shopping cart, let's say, you know, an online e-commerce site, right? And it takes a certain amount of steps to fully process an order. Updating customer information, processing credit card information, sending out email notification that your order's been processed, and maybe even some logging with some cool login tool if you want. And I've broken these 4 different steps out into subcomponents so they can be made more autonomous and so they can be tested a lot easier. So we're going to have a commerce class that's going to depend on 4 other classes. Now, the first example I'm going to show you is a coupled example where the commerce class will not even compile without its dependent classes. The main thing is not that. The main thing is the lack of testability. And what I mean by that is that if you have a commerce class that uses a sub-dependent class called a billing processor, think about what that billing processor does. It's going to process your credit card. What about another processor, another class? I call these processor classes. What about another class that updates the database with your customer and order information? Now, if you're going to take a unit test and instantiate the commerce class, you're now also instantiating these dependent classes. And you're coupling and tying yourself to the act of updating a database and, worse, processing a credit card. So your unit test is not autonomous. Your unit test is not what they call it in the service-oriented world, idempotent, which means you should be able to run it over and over and over again without causing any damage. Anybody ever hear that term, idempotent? Is that the stupidest word in the world? You can't even pronounce it. I don't know who came up with that, but it's a